Begin our discussion of the universe by talking about the things that make up the universe, which is going to be the stars. So when you look up into the night sky, 64% of those twinkling things in the night sky consist of one star, and then those one stars could have planets that are in orbit around them. So each of those objects could actually have a solar system that goes with it. About 30% of the objects that are twinkling in the night sky are going to be binary stars. So that means it's going to be two stars that are in orbit around each other. And then about 5% of the time, those objects are going to be three stars that are going to be in orbit around each other. So that still leaves you with 1% of the night sky, and that could consist of like four stars or five stars that are in orbit around each other. But it is highly unlikely that that happens, because what will happen is that the stars will collide, and then you will end up with either one star or two stars or three stars. So you'll notice that the vast majority of the night sky is either just one star or two stars in orbit around each other. Now, what kind of stars are they? So there are two basic kinds of stars: population 1 type stars and population 2 type stars. So let's first talk about the population 2 type stars. So you got population 2 type stars, and they are going to represent the original stars that formed after the Big Bang. So what are some characteristics of population 2 type stars? First, it says that they are element poor. So a element poor star means that it's only composed of hydrogen and helium. And so that would make sense if these were the original stars to form after the Big Bang, because the only materials that were basically formed by the Big Bang was hydrogen and helium. Okay, another thing it says about population 2 type stars is that they're old. Now, our star, which is a population 1 type star, is old. So our star is 5 billion years old. However, these population 2 type stars started forming approximately a billion years after the Big Bang occurred. So that means that they are much older than the population 1 type stars. Another thing about the population 2 type stars is they're found in the halo of the galaxy. So if we were to draw a picture of the Milky Way galaxy, which is a spiral galaxy, it has a bulge in the middle, and then it's going to have a disk that goes with it. Okay, then surrounding this disk is going to be a halo of these population 2 type stars. So it's a spherical structure that is going to surround the galaxy. Now, it makes no difference whether this is a spiral galaxy or an elliptical galaxy. So all galaxies are going to have this halo that surrounds them, and then this halo is going to be composed of these population 2 type stars. Now, this gives us a clue as to where did the galaxies come from. Because if you think of this picture, instead of being a galaxy, what if this thing in the middle was a star, and then this stuff out here, that's the solar system, and then what did we call this area that was spherical and it surrounded the solar system? It was the blank cloud. Okay, it was the Oort cloud. And in the Oort cloud, you had the remnants of the material that formed the solar system. So this time, the halo composed of these population 2 type stars is going to represent the original stars that formed the galaxy in the first place. So how do stars form? Okay, well, we already studied that in unit number 3. So you're not going to be tested on that on this next exam, on the whole idea of the gas cloud collapsing and then heating up and spinning and then igniting. So we're not going to be talking about that because you already learned it. However, we do need to know, how can a population 2 type star turn into a population 1 type star? And so its characteristics is it's element rich. So in addition to hydrogen and helium, population 1 type stars, such as our star, also contain carbon and oxygen and silicon and heavier elements. Now, our star is only converting hydrogen into helium. So that's the only thing that it is currently undergoing nuclear fusion inside the star. However, our star does contain these other heavier elements. So where did they come from? Okay, so this diagram shows how population 1 type stars evolve, and this is just really a review of what you learned back in unit number 3 when we talked about the formation of stars. So that we're going to start off with a population 2 type star that is going to be composed only of hydrogen and helium. Okay, then we know that what's going to happen is that the hydrogen is going to be converted into helium until that star runs out of hydrogen, and then the core is going to shrink, it's going to heat up, and then heavier elements can be forged in the core of that star, and then the outer part puffs up and turns into the red giant, which we're not concerned about. Okay, then eventually though, this star is going to run out of fuel. Okay, if it doesn't get to the element iron, then what will happen is the outer layers, which are going to be composed of hydrogen and helium, are going to be ejected into outer space. And then that material then can become the raw material for other stars to form. Okay, but if it does manufacture iron, then what's going to happen is it's going to have a supernova. And then what will happen is all of those elements that were in the core, those heavier elements that had been forged, are going to be scattered into the universe, and then they can become the raw materials for new stars to form. So that you start with a population 2 type star that only consists of hydrogen and helium. It then explodes, and then its heavier elements are ejected into the galaxy and then can be collected back together again as another nebula, and then they can be turned into another star, which then would be a population 1 type star. And now this population 1 type star can go through its life cycle and can explode or can jettison its planetary nebula, and then its materials can be incorporated into another population 1 type star. So this is called the star-gas-star cycle. And so you can read about it in your textbook. But the idea is that gas gets incorporated into a star evolves, and then as it dies, it gives off those gases and particles back into the universe that can be incorporated into another nebula, which can turn into another star. We think that our sun is actually a 3rd generation star. So that in this neck of the woods of our galaxy, there was a population 2 type star, and then it blew up, and then its debris got incorporated into another star, which probably blew up, and then its material got incorporated into the gas cloud that eventually became our sun. So, pretty interesting. All right, now that we know what stars are, we're next going to talk about star clusters.